Electronics tutorials, particularly those focusing on microcontrollers and stepper motors, can be valuable resources for hobbyists, students, and professionals alike. Microcontrollers are small, programmable computers on a single integrated circuit. They are used in a wide variety of applications, from simple remote controls to complex engine control systems in automobiles. Understanding microcontrollers involves learning about their architecture, programming languages like C or assembly, and how to interface them with various sensors and actuators. Stepper motors, on the other hand, are electromechanical devices that convert electrical pulses into discrete mechanical movements. The shaft of a stepper motor rotates in precise increments when electrical pulses are applied to it in the correct sequence. These motors are widely used in applications requiring precise positioning and speed control, such as robotics, computer peripherals like printers, and CNC machines. Tutorials on these topics often cover the fundamental principles, practical applications, and step-by-step instructions for building and programming projects. A good electronics tutorial website might include, firstly, introductory articles explaining basic concepts like voltage, current, resistance, and Ohm's law. Secondly, detailed explanations of microcontroller architecture, including the central processing unit or CPU, memory, and input/output or I/O peripherals. Thirdly, programming tutorials covering languages like C and assembly, with examples of how to control microcontroller functions. Fourthly, information on interfacing microcontrollers with various sensors such as temperature sensors, light sensors, and accelerometers. Fifthly, guidance on using microcontrollers to control actuators such as LED, relays, and motors, including stepper motors. Sixthly, stepper motor tutorials explaining the different types of stepper motors, such as unipolar and bipolar motors, and their driving methods. Seventhly, example projects that demonstrate how to combine microcontrollers and stepper motors to create useful devices such as a robotic arm or a 3D printer. Eighthly, circuit diagrams, code samples, and troubleshooting tips to help learners overcome common challenges. Ninthly, links to relevant datasheets, software tools, and online communities for further learning and support. Understanding electronics requires a solid foundation in basic electrical principles. Voltage, measured in volts, represents the electrical potential difference between 2 points in a circuit. Current, measured in amps, is the flow of electrical charge. Resistance, measured in ohms, opposes the flow of current. Ohm's law, which states that voltage equals current times resistance, is a fundamental relationship that governs the behavior of electrical circuits. When working with electronics, it is important to be aware of safety precautions. Always disconnect power before working on circuits. Use appropriate tools and equipment. Be careful when working with high voltages. It is also essential to follow the manufacturer's specifications for components and devices. Overloading components or exceeding voltage or current limits can damage them and create a safety hazard. When selecting components, it is important to consider their ratings and specifications. Resistors, for example, have a power rating that indicates the maximum amount of power they can dissipate without overheating. Capacitors have a voltage rating that indicates the maximum voltage they can withstand without breaking down. Transistors have current and voltage ratings that must be observed to prevent damage. Microcontrollers are often programmed using Integrated Development Environments or IDE, which provide a text editor, compiler, and debugger. The compiler translates the high-level programming language into machine code that the microcontroller can execute. The debugger allows you to step through the code, inspect variables, and identify errors. When interfacing microcontrollers with external devices, it is important to understand the different communication protocols. Serial communication protocols, such as Universal Asynchronous Receiver Transmitter or UART, Serial Peripheral Interface or SPI, and Inter-Integrated Circuit or I2C, are commonly used to transmit data between devices. Parallel communication protocols, such as Parallel Input/Output or PIO, can also be used for faster data transfer, but they require more pins. Stepper motors are available in different configurations, including unipolar and bipolar motors. Unipolar stepper motors have a single winding with a center tap, while bipolar stepper motors have two windings without a center tap. Bipolar stepper motors generally provide higher torque than unipolar stepper motors, but they require a more complex driving circuit. Stepper motor drivers are electronic circuits that control the current flow through the motor windings. These drivers typically use transistors or integrated circuits to switch the current on and off in the correct sequence. Microstepping is a technique that allows stepper motors to achieve finer resolution than their basic step angle. By controlling the current in the motor windings, the motor shaft can be positioned at intermediate positions between full steps. This reduces vibration and noise and improves positional accuracy. When designing electronic circuits, it is important to consider the power supply requirements. The power supply must provide the correct voltage and current to the circuit. It must also be stable and reliable to prevent malfunctions. Linear power supplies provide a stable voltage, but they are less efficient than switching power supplies. Switching power supplies are more efficient, but they can generate noise that can interfere with sensitive circuits. Simulation software can be used to model and analyze electronic circuits before they are built. This can help to identify potential problems and optimize the circuit design. Simulation software allows you to simulate the behavior of components, analyze circuit performance, and test different design options. Prototyping boards, such as breadboards and stripboards, are useful for building and testing electronic circuits. Breadboards allow you to quickly connect components without soldering, while stripboards provide a more permanent connection. Soldering is the process of joining electronic components together using solder. Soldering requires a soldering iron, solder, and flux. It is important to use proper soldering techniques to create reliable connections. When troubleshooting electronic circuits, it is helpful to have a multimeter, oscilloscope, and logic analyzer. A multimeter can be used to measure voltage, current, and resistance. An oscilloscope can be used to display waveforms and analyze signal behavior. A logic analyzer can be used to capture and analyze digital signals. Online forums and communities are valuable resources for learning about electronics. These forums provide a place to ask questions, share knowledge, and collaborate with other enthusiasts. There are many websites and online courses that offer electronics tutorials. These resources can provide structured learning paths and help you to develop your skills. Consider safety first.